All right, so this is the video for 8.1 Part B or Part 2, and we're going to talk a lot about the perimeters and the areas of similar figures. Now, we've done a little bit with perimeters on 8.1a, but we're going to go more in depth here, and then we're going to introduce the areas as well. So go ahead and find this foldable in your interactive student notebook packet. It should be next in line because what's on top should already be pasted into your interactive student notebook. But go ahead and find this. It wants you to cut out a square, so go ahead and cut it out. And if you want to go ahead and fold it up, you can, or you can wait and fold it up here at the end. So take a minute and do that. All right, so if the scale factor of the two figures is A over B, then the ratio of their perimeters is also A over B. Okay, so in other words, the ratio of the perimeter is the same as the ratio of their sides. Okay, you don't have to write both of these, but just know that the ratio of the perimeter is the same as the ratio of the sides. Okay, now that's not true for the area because the ratio of the area is A over B, and you have to square it. Okay, and if you do this, because this A over B is in parentheses, this square goes to both the A and the B, so you can actually write this as A squared over B squared. Okay, so if I put this in other words, you must square the ratio of the sides to get the ratio of the areas. All right, so let's look at this example. Okay, it says, are the triangles similar? If so, find the ratio of their perimeters. Okay, now we haven't really talked about if the triangles are similar, so I'm going to say yes, they are similar by angle. Okay, and this probably doesn't make sense now, and that's okay, but it will. And I'm going to highlight these two angles. Hopefully after our next lesson, this will make sense. So just take it for word, they are similar. Okay, but it then says find the ratio of their perimeters. So the ratio of their perimeters is going to be the same as the ratio of the sides, guys. And so these are corresponding sides. So the ratio of their perimeters, well, first of all, I'm going to say the scale factor is 3 over 4. And therefore, the ratio of the perimeters is the same. So it's also going to be 3 over 4. Okay. Now, find the ratio of the areas. So the ratio of the areas, remember, we have to square this. So we're going to take the ratio of the sides and we're going to square it. And when we do that, we square both the top and the bottom. So 3 squared is 3 times 3 is 9. 4 squared is 4 times 4, which is 16. So the ratio of their areas is 9 over 16. All right, so I want you to go ahead and do example 2 on your own. It tells you that the polygons are similar, and then it tells you the ratio of their sides is 3 to 5. Okay, so use the example before and find the ratio of the perimeters and also the ratio of the area. So go ahead and do that on your own and then we'll go over it. All right, so hopefully you've already attempted this. The ratio of the perimeter is the same as the ratio of the sides, which is just 3 to 5. Or if you wanted to write 3 to 5, this is the same thing. Okay, now the ratio of the area, we use the ratio of the sides, but we must square it. And remember, when we do that, we have to square the numerator and we have to square the denominator. So 3 squared is 9 and 5 squared is 25. So the ratio of the area is just 9 over 25. All right, let's look at example 3. It says the corresponding sides of two similar rectangles, so we're told they're similar, are in the ratio 3 to 4. So 3 to 4 is the scale factor, the ratio of the side. The ratio of the area, we're talking about area here, of the smaller rectangle is 96 inches squared. Find the area of the larger rectangle. Okay, so the first thing we want to do is we want to find the ratio of the area. Okay, and remember that the ratio of the area is the ratio of the sides, but we have to square it. Okay, so this is just 3 squared over 4 squared, which is 9 over 16. Okay, so the ratio of the area is 9 over 16. Okay, now I want to set up a proportion to find the area of the larger triangle. So 3 over 4 equals, well, the 3 here, guys, is obviously the smaller triangle over the larger triangle. And this is our scale factor, okay? So the ratio of the area is 9/16, so I'm going to say 9 over 16, so smaller over larger equals the area of the smaller, which is 96, over the area of the larger, we don't know. I'm just going to say that's A. Okay, now we should be able to solve this. We're going to cross multiply. So we would get 9A equals 96 times 16. Or 9A equals 1,536 divided by 9, I get the area is roughly 170.67 inches squared. All right, I want you to go ahead and try to do this one on your own. Use example 3 to kind of guide you, and then we'll go over it. All right, so hopefully you got 385.7. Okay, the first thing you need to do is find the ratio of the sides. So just set up a proportion. So 7 over 15 is the ratio of the sides. And then you want to find the ratio of the areas by squaring the ratio of the sides, which gives you 49 over 225. Okay, now you're going to use this scale factor. So 49 over 225, so we're doing the small over the large, is going to equal the area of the small, which is 84, over the area of the large, which we're trying to find out. Okay, and after you set up this proportion, we're going to cross multiply and then solve, and you get 385.7 centimeters squared. All right, so let's look at example 5. So it says the areas of two similar rectangles are 32 and 72. Okay, so we can say that the ratio of the areas equals 32 over 72. Okay, now remember, in order to get the ratio of the areas, this has been squared. Okay, so we want to find the ratio of the perimeter. Okay, so to find the ratio of the perimeter, that's just going to be the ratio of the sides. And remember, this has been squared. Okay, so we want to do the opposite of square. We want to go backwards. So the opposite of squaring something is the square root of something. Okay, so the ratio of the sides is, we want a square root of 32 over square root of 72. Okay, now 32 over 72 goes to 4 over 9. So I'm going to simplify this to the square root of 4 over the square root of 9. Okay, well, the square root of 4, guys, is just 2. The square root of 9 is just 3. So the ratio of the sides is 2/3, and therefore the ratio of the perimeter, which is the same thing, 2/3. All right, I want you to go ahead and do number 6. This one's very, very similar to example 5, so make sure you look off of that, and then we'll go over it. All right, so when I do this, the ratio of the area is 8/32, okay? And 8/32 reduces to 1/4. Now remember, when we found the ratio of the area, we'd have to square this. So to undo the square would take the square root of both the top and the bottom. So the ratio of the sides would be the square root of 1 over the square root of 4. But guys, the square root of 1 is just 1, and the square root of 4 is just 2. So the ratio of the sides is 1/2. And guys, the ratio of the sides and the scale factor, these are the same things, okay? So the scale factor is just 1/2.